Alright, this video is about writing an equation from a graph. It's continuing in our polynomial series. Okay, so when you write an equation in a graph, you have to look first at where is the graph crossing the x-axis. Okay, those are the zeros. So we notice it crosses right here at 0, 0. And we notice it crosses right here at -1, -2, -3, 0. Okay, from that, we can write factors. So we have our zeros, and we're going to write factors. And a factor basically just takes our x value and switches the sign. So to get a -3 for x, I'm going to have x plus 3. To get a 0 for x, I'm going to have x plus 0. You could have minus, but it doesn't really matter. Now you look at multiplicities. Okay, remember multiplicities either 1, a 2, or a 3. A 1 means it just crosses through like normal. 2 means it bounces, and 3 means it flattens on the x-axis. So a 1 would be like right here, where it's just crossing through. This is a multiplicity of 1, so this has a power of 1. X plus 0, well, this one right here, see how it flattened out? This would have a multiplicity of 3. So if I clean this up, I have x to the third times x plus 3. Okay, and so when I finish my equation, I would distribute out the x cubed and have y equals x to the fourth plus 3x cubed. And that would be my final answer, putting it in standard form. Let's try another one. Okay, let's analyze this graph. Where does it cross the x-axis? Over here. 1 to -3 again. Right here where x is 0, and right here where x is 3. So let's see, our factor would be x plus 3. This one is just x, or you could put x plus 0 if you'd like. This one is a positive 3, so this would be an x minus 3. Now look at multiplicities. This just goes straight through the x-axis, so it's a multiplicity of 1. This one goes straight through, so it's a multiplicity of 1. X minus 3, however, has a multiplicity of 2, so it's squared. Now, you're going to have to multiply these out to get it into standard form, okay? What I would recommend is you multiply 2 at a time. All right, so like these two, if I distribute the x, so if you want to rewrite it, you can do x plus 3, and distribute the x, you get x squared plus 3x. Now this, remember, x minus 3, it's squared. So I'm going to have to do FOIL or box method, and I get x squared minus 6x plus 9. Now I'm not finished because I have to multiply this times this, and that's going to require a big box. Okay, so give yourself space and give yourself a box. So I've got x squared minus 6x plus 9, and then x squared and 3x right here. I won't have you do this too often, but you do need to know how to handle it. So then I would just multiply my boxes. X squared times x squared is x to the fourth. Negative 6x times x squared is negative 6x cubed. 9 times x squared is 9x squared. 3x times x squared is 3x cubed. Negative 6 times 3 is negative 18x squared. 9 times 3 is 27, and then there's an x. And if you've done it correctly, your diagonals will add and be like terms. So when I write my final equation, I'll have x to the fourth. Negative 6 plus 3 gives me negative 3x cubed. My x squared terms, I have negative 18 plus 9, so that's negative 9x squared plus 27x. Okay, so that's my answer. Now, writing a polynomial equation, what if they just give you this? And what this is just the actual x values off the graph that we indicated on our graph previously. So the first thing you want to do is make them factors. So to get a factor of 0, it's just x. To get a factor of -2, that would be x plus 2. You just change the sign. And to get a factor of positive 4, this would be x minus 4. Write an equation given the multiplicities. Okay? So these all have a multiplicity of 1, or they would be indicated otherwise, like it would be a double, a single, or a triple. But these are just singles. It's kind of understood. So then you multiply it out. So I would multiply these two out first, okay, using box or FOIL. So I would have x squared minus 4x plus 2x minus 8. gives me x squared minus 2x minus 8. But then I have to multiply this x by all of it. So then my final answer would be x cubed minus 2x minus x squared, minus 8x. That would be my final answer. So in example 4, again, these all have multiplicities of 1. But let's write our factors. So this would be x plus 3 times an x times x minus 8. So I would multiply the binomials together first. Get the hard stuff out of the way. The box or FOIL that, I still have the x on the outside. I would get x squared minus 8x plus 3x minus 24. Combining like terms, I have x squared minus 5x minus 24. And then distribute that x out. So you'll have x cubed minus 5x squared minus 24x. So again, we're writing equations. Write an equation for the polynomial that has the given zeros and multiplicities. Just set these up. So we're going to leave, that's code for leave in factors. Okay, we don't need to multiply these out because they get nasty. All right, so let's first set up our equation. To get an x of negative 5 means I had a factor of x plus 5. And x is 0, that means it's x. If it's doubled, that means it was squared. X is positive 2 means I had a factor of x minus 2. And this has a triple multiplicity. Now when you write this, you would put the x squared first. So I'm going to say y equals x squared, and then your highest exponent, x minus 2 cubed times x plus 5. Okay, so this is what we mean in factored form. Leave it there, don't multiply it out. Now in this one, let's see what factor gives me a negative 1 and x plus 1. What factor gives me positive 6? X minus 6. Now this is a double, so it's squared. And this x is 0, so it's just x, and it's to the third power. So I would put my x to the third first, times x minus 6 squared, times x plus 1. And that would be my final answer. Now, try this one on your own, and we'll begin with this one in class. Good luck. See you then.